Okay. All right, so we're going to need complex numbers in order to solve some quadratic equations because sometimes the quadratic equations don't have real answers. And the idea is actually a really simple one. If I ask you to solve x squared equals negative 25, there's not a real answer for that because it can't be negative 5. Negative 5 times negative 5 is positive 25. And it's definitely not positive 5. 5 times 5 is 25. So in order to solve an equation like x squared equals negative 25, we need imaginary numbers. It might seem silly, like to have imaginary numbers. You think of like that's something that's for fiction, it's not for math class. But imaginary numbers are placeholders that you can use to solve problems that actually have real solutions somewhere else. For now, we're just learning about the placeholders though. But in later classes, you may learn some more ways that imaginary numbers will actually be useful. So, the number I is our imaginary number, and it's equal to the square root of negative 1. And then if we square I, that would cancel out your square root, and you would just get negative 1. So those are two things that are important to know. I is the square root of negative 1, and then I squared is negative 1. We have something called a complex number. So usually you don't just have an imaginary number, you have a complex number that has a real part and an imaginary part. Sometimes we ask questions that are powers of I. Like if I asked you, what is I to the 100th power? Let's think about that for a moment. I to the 100th power. I know that I to the first power is I, and I know I squared is negative 1. And what happens if I square negative 1? What do I get? 1, right? So if I square negative 1, I get 1. If I square I squared, I get I to the 4th. So I to the 4th is just the number 1. Okay? I to the 4th is 1. I to the 8th is also 1, because I to the 8th is I to the 4th times I to the 4th. So I to the 8th is 1. I to the 12th is 1, because it's 1 times 1 times 1. So anytime your exponent is a multiple of 4, you're going to get 1 as your answer. Okay? So I to the 4 is 1. I to the 8 is 1. I to the 12 is 1. I to the 40th is 1. I to the 100th is what? Is it a multiple of 4? Yeah, 100 is 4 times 25, right? So I to the 100 is 1. Now sometimes it's hard to know if a number is a multiple of 4, so an easy method for doing that is dividing 100 by 4, and we get no remainder. It's 25.00, no remainder. So we know that it divides evenly. No remainder. Okay, we know it divides evenly. Now, 101, if I asked you I to the 101, we know that I to 100 is 1, and then we have just one more I, so 1 times I is going to give me I. Some people think of it as like this cycle where you go around and you just count 4s. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Once I get to the I to the 100, I'm back at 1. And then if I need one more I after that, I'm going to be at I. Another way to do it is with dividing. So if I divided, let's say if I wanted to do I to the 134. I to the 134. I can divide 134 by 4 and see what my remainder is. So I'll do that real quick. Let me open up Desmos. 134 divided by 4, I get 33.5. Okay, and that 0.5, the 0.50, it tells me that the answer is going to be negative 1. So the remainder tells you if it's the answer is going to be I, negative 1, negative I, or 1. So these are just simple problems where we raise I to an exponent, and we want to know what it equals. the simplest form.
So can you, any number you can, or like I to any number you divide it by 4?
You can just divide the exponent by 4, and if it gives you no remainder, then it's just going to be 1. And if it gives you a remainder of 0.25, it's going to be I. A remainder of 0.5 is going to be -1. A remainder of 0.75 will be -I. And then a remainder of nothing is going to be 1. I'm going to give you guys one problem to try, okay? We're going to do I to the 47. Okay, so do I to the 47, and on your calculator, divide 47 by 4. See what your remainder is. Look around at your group. If no one in your group has a calculator, then you could offer to get them for your whole group. All right, 47 divided by 4, what do we get? 11.75, good. 47 over 4 is 11.75, and then looking at our chart, that means that the answer is what? It is -I. So see the 0.75 here? That gives us the answer of -I. All right, I'm going to turn the page. This is not the main thing that we're learning, but it is something that comes up every once in a while. It might come up like on an SAT problem or something. So it is good to know how to do powers of I. And your calculator doesn't really do powers of I. Like, your calculator knows that non-real numbers exist, but it doesn't do much with them. Okay, can I turn the page? Is that okay? For some reason, my camera's like all askew today. Okay, on the back. We're going to simplify some radicals, and it just has this extra step because we have a negative, and other than that, it's just like what we've been doing on the warm-up, okay? So let's look at the first one. In problem number 1, I have square root of -16, and I can't do that. So what I'm going to do is break it into the square root of -1 times the square root of 16.
You can't do it because it's negative or what?
Yes. Yeah, we can't do the square root of a negative number with real numbers. We need imaginary numbers. So now I know the square root of -1 is I, and the square root of 16 is 4. And then the way we write this is just like what we would write if we had a variable. If we had x times 4, we would write 4x. If we have I times 4, we write 4i. It's not a variable. It is actually a non-real number, I, but you treat it the same. Okay, done. All right, I want you to see if you can continue working on 1 through 6. You really do have all the tools you need to be successful there. I will come around and give you some help, and then once we get to like a good stopping point, I'll go over those problems.
So if we were traditionally...
All right, so in number 2, you're going to do the same thing where you break out the -1, and then I have square root of -1 times square root of 400. And you could do a factor tree for 400, but always check and see if it's a perfect square. So on the calculator, if you type square root of 400, you get what number? 20. Did anybody try doing square root of -400 on their calculator? No, because when you do that, it says non-real answer, and it gives you nothing helpful. But once you take out the negative, then you can do square root of 400 and get a 20. So you need to be the one who knows that this part gives you an I, and then the calculator will tell you the square root of 400 is 20, and then just rewrite it with the 20 first, so you get 20i. For number 3, we have square root of -12. So square root of -1 times square root of 12. On the calculator, I don't get a whole number, so I can't use that number. I got to do a factor tree. So if you guys wrote something down like 3 point something, we can't use that number. We need to do a factor tree. So we're going to do 3 times 4 and 2 times 2. And so then I'm going to get square root 2 times 2 times 3. This one has a pair, so it comes out, which is 2 root 3. The square root of negative 1 is I, and so I need to put these two together, the I and the 2 root 3. Some people are writing I times 2 root 3. Technically it's right, but usually we put the 2 first. Do not put the I after the root because it often looks as if the I is under the root. You will never have an I under the root. So the way you put your answer together is first put the 2, then the I, and then the root 3, like that. Any questions? Okay, we're going to do the same thing for square root of negative 50. So square root of negative 1 times square root of 50. That's not a perfect square, so we have to do the factor tree. 25 times 2 and 5 times 5. So the square root of 50 is root 5 times 5 times 2. That 5 can come out, so 5 root 2. The square root of negative 1 is I, and when you put them together, first the 5, then the I, then the root 2. Alright, so you can see how we're building off the skill from last class where we simplified the square roots. Because now we just have to do that extra step where we make the square root of negative 1I, and then we do the same thing as last class. In number 5, it has square root of negative 50 plus square root of negative 8, and I just did square root of negative 50, so I don't have to redo that. It's like right here on my paper. So this one I know is 5I root 2. For the square root of negative 8, I'm going to do negative 1 times root 8. And that's going to be 4 times 2, 2 times 2. Which is going to be square root of 2 times 2 times 2. That one comes out. And putting that together with the I, I'm going to have plus 2I root 2. 2I root 2. Negative I where? Oh, right here? That's just negative 1.
From what?
So the root negative 8, just like with all the other roots of negative numbers, I always take the negative 1 out so that I can do the square root of positive 8. So remember, negative 1 times 8 is negative 8. Instead of writing negative 8, because I can't do the square root of negative 8, it's not real, I split it up into the square root of negative 1 times the square root of 8. I'm allowed to do that because negative 1 times 8 is negative 8. Okay. All right. Are these like terms? 5I root 2 and 2I root 2. They are like terms because the only thing that's different is the coefficient. They both have I and they both have root 2. When you add like terms, you only add the coefficient and nothing else changes. So we only add the 5 and the 2 and we get 7I root 2. All right, in number 6, do both terms get an I? The square, no, right? Because you see how one of them's real? Square root of 36 is just what number? It's just 6. So I have 6 minus, and I'm going to split this one up into the square root of negative 1 times the square root of 49. What's the square root of negative 1? I. What's the square root of 49? Square root of 49? 7. So I have 6 minus 7I. And those are not like terms because one has an I and one doesn't. So you're just done there. All right, I'm actually going to lower it so that I think some people are still catching up on this problem here. So now you can do 3, 4, 5, 6. Yeah, so the 3 combines with a negative 8. And 3 minus 8 is going to give me negative 5. And then the negative 7I combines with the negative 2I. And that makes negative 9i. All right, and I had forgotten to start recording, so I'm just going to go over this one again. We just added the like terms to get 10, and then here we added the like terms to get 3i. Here, I distributed the subtraction in my first line, and then I combined like terms. All right, so combining like terms is really no different, and there's only one thing that's different about multiplying. When you multiply and you distribute, you're going to multiply the 3i times the 7 and the 3i times the 2i. Just like before, 3i times 7 will be 21i. And 3i times 2i is going to be 6i squared. And if you were working ahead, you probably got that. However, can we think back? We know what I squared equals. What does I squared equal? -1, yeah. I squared equals -1. So if you stopped here, you need to do one more step where we replace I squared with -1. So we have 21i plus 6 times -1, which just makes -6. So 21i minus 6 is your final answer. And for some reason, I keep stopping my recording. I just want to make sure I explain this problem on the recording. 3i times 7 was 21i. 3i times 2i is 6i squared. And then we replace the I squared with -1. And then we have our final answer, 21i minus 6. So everybody's working on 10 now. So in this problem, we are going to distribute the 5 times the 2 to get 10. The 5 times the 4i to get 20i. 3i times 2 gives me 6i. And 3i times 4i gives me 12i squared. All right, these two are like terms. So I add those to get 26i. And then when I get here, am I done? No, because I need to replace I squared with what? With a -1. So I have 10 plus 26i. When I replace I squared with -1, this will become -12. And then I can combine the 10 and the -12 to get -2 plus 26i. And now I'm done.